Good morning, folks. This is week 6, lecture 1, and you can consider this as a review of what type of problems, and this is only a sample. Please keep that in mind. You're responsible for everything that I've done in the class on the Friday's midterm, but some sample problems from previous midterms, okay? Our midterm is on Friday, right? Okay, so let me do this problem for you. You look at this, immediately you realize that this has to be done with solid elements. And here's the situation. We have the inside of these holes are clamped, and then you're subjecting these faces into tensile loads of 200 psi, okay? And obviously we're using solid elements, and it says use as many planes of symmetry as possible. And in this particular problem, you have a 3 planes of symmetry: vertical, horizontal, and through the thickness. Now, the other thing is that it says make sure that there is a local mesh refinement around either one of these holes. Okay, so you have two choices. You can make the whole thing and then split it 3 ways, or you can just make half of the model, or actually 1/8 of the model. That's what I'm going to do, okay? So let's go ahead and do that. For example, this thickness, which is 1, because you're cutting through the width, or the thickness, is going to be 0.5. All right, so we start with the part design. This is part design, okay, because you're making solid object. Immediately I save it. File, save management, save as, desktop, units, so everything is in inches, etc. So on that vertical plane, I will sketch something that resembles 1/4 of that front face. And there are different ways of doing it. You do the way you want to. This is how I'm going to do that. So, for example, I'm going to go up here. Actually, let me do this. Do it like this. So, like that, like this. And there's going to be an arc here. We clean it up. And from there all the way down here. Okay, let's clean this up first of all. Here's the front view. Oops. All right. So, for example, let's see now. This center, control that line. They're going to be coincident. Let's try it again. Center, control that line. Control. Yeah. It's going to be coincident. Okay. And I want this thing to come in tangentially, and there are different ways of doing it. One of them is, for example, is to draw a horizontal line and make it into construction entity, which is right here. And then you can, yeah, and then you can make this circle control that line tangent to each other. No, it is tangent. Good. Okay, very good. So let's give some dimensions here. The dimensions, I already put it on the screen, so I'm not going to bring it up here. This is 3 inches, okay? Okay, and now this is 1. This dimension is 1 inch. This height is 1 inch. Okay, what else do we know? That radius is, the radius of the circle is also 1 inch. Okay, and that height, this whole height is oh, this angle, this whole height is not given, but that angle is. So the angle between here and here is 120 degrees. There we are. And I'm pretty sure this is what we have. Okay. Hopefully I didn't make a mistake here. Everything looks okay. Now there's a circle there, concentric with this, not construction, of course. And then we have to use a quick term to clean it up. So let me see now. Quick term is here. The eraser. Get rid of this. Get rid of that. Yeah, that's good. And the radius of that circle, that inner circle, the radius of it is 0.5. I'm pretty sure that 0.5. I'm pretty sure that dimensions are correct. Exit. And pad it by half the thickness, 0.5, because we have cut it also along the thickness. There we are. That is the geometry. Everything is made out of steel, so apply material. I think it's made out of steel. Good. And that's pretty much it. So you're going to go to analysis and simulation, generative structure analysis. Katia sees a solid object, immediately it measures that for you. You're asked to refine around this hole. I'm not giving you the value because all I want to do is to make sure you can do it. Okay, so notice that it's this much. I have suggested that unless you're told, everything is linear and default size and SAC. Now, if you right-click Mesh Visualization, you'll see that the mesh is there and it's finally around this hole. You can see that, okay? So deactivate that. All right, so we know that the inside of this is clamp, okay. And we have surface sliders because of the fact that we have used symmetry to cut this thing many ways. So this side, the bottom side, and the back side, or the entire front side, it really doesn't matter. You say okay, and you are applying a pressure to that face, and the value of the pressure is actually pulling, so that's correct, tensile, and the value is 200 psi. So please do not divide this thing by anything. Pressure is already taken all the divisions into account. So 200 psi. And before I run it, I'm going to save this. So we go File, Save Management, Analysis, Save As in that same folder, Problem 1, Analysis 1. You say OK, and we're going to run it. Nothing exciting is going to happen. Okay, this elongates. Yep, you can animate it if you want. You're going to have some stress distribution around the hole and around this discontinuity, geometric discontinuity. Okay. All right. And that's pretty much it. So we're going to save this thing and just, you're done with problem number 1. Okay. So I'm going to kill that and that. So you go to problem number 2, which is right here. Now, this problem says use the most appropriate element. You can see that, first of all, this the geometry like that, clamped, and the inside, this middle point is subjected to a force and a moment. However, I'm not giving you the value of the force or the moment. I'm saying that you apply a deflection of 0.01 here, 0.001 inch downward, and 2-degree rotation about the y-axis. Now, this is similar to the problem that I've already given you as a sample. Now, it says use as many planes. The most appropriate element is obviously beam element. You should be using a beam element. You should not use solid element. Obviously, it's not shell. Now, use as many planes of symmetry. So that when you look at that, there is one plane of symmetry, and that is XZ. Okay, so just use the. You can make half of the model, or you can make the whole model and cut it. And that's exactly what I'm going to do. Half of the model instead of making it and then cutting it. Now, The other thing is that when it comes to this piece, notice that these have different circular cross sections, this piece and that piece. But because this is all, because this is a planar sketch, you can draw it in a sketch and don't forget to join it if you're going to go that route. Okay, and then this has to be done in a either separate sketch or in space. It's up to you. So yeah, what I'm going to do is the choice is yours whether you want to do these things as a sketch or as a since the points I've given you already here, I might as well go and type in these points, create these points, and then go ahead and just literally connect them with lines and circles. I don't know. Maybe. Okay, that's fine. That's fine. That's what I'm going to do. So we go here. We start with the part file. Part file. Okay. So first of all, it may be easier for me to because notice that these points, for example, these points E, F, G, and H all have the same 1.5 y coordinate. Maybe it's easier for me to go and make a plane which is 1.5 away and just sketch in that plane. Yeah, that's what I'm going to do. Remember, these are all up to you. So I'm going to create a plane 1.5 away from that. Okay, and on that plane, I will sketch something that looks like this. Okay, and I have all the coordinates. So let me see. Why don't I do that? So I'll make it and fix it. Okay, how about that? There is my sketch. And based on those coordinates, we can figure out what these dimensions are. So the distance from E to F is actually 1. So this is 1 inch. This is 1 inch. The distance from F to G is simply 2 inches. So this is 2 inches. And the radius is obviously 0.5. So that radius is 0.5. 0.5. Say OK. Exit. OK. And why don't I join this thing? I better join it. So to join, you have to go to generative shape design. Here, you go like that. Shape. Generative shape design. Here's the join operation. You select this. Oops, select this. And say OK. And by the way, while you're at it, you might as well make everything out of steel. So apply material on that part. I think it was steel. Say OK. Good. Now, I want to create this other point here. In other words, that point, which has the same same location as that, except that it goes by half that length. Half that length is, let's see now, if you look at A and E, the length is 3 inches. So from A to E, so this distance seems to be 3. You look at A to E, the difference in the y's is 3. Sorry, difference between y is 3. So this distance is 1.5. This distance is 1.5. So here's what I'm going to do. Entirely up to you. I'm going to create a line, point and direction. This is the point. The direction is direction y. in the other direction, and 1.5. 1.5, and that takes care of the model. Okay. Now, there's two things you can do. We should join these again. Okay, so I'm going to join this so that when I mesh it, everything is meshed at once and there are no duplicate nodes at this corner. That's pretty much it. So now we're going to go to what do I save this thing? File. This is how you're going to do that on the test. Save management. Save as. No, cancel. Yeah, save as. Okay. Okay. And yeah. Let me see for a second. Yeah. So we go to generative analysis and simulation, generative structure analysis, static analysis. Okay, so we're going to do a beam meshing. So because we joined it, we can do it all at the same time. Yeah, that's good. 1D property, you select this. The cross section is circular, cylindrical. Radius of the cross section is, well, we're going to make everything 0.05, but then we have to come back and change the horizontal member. Okay, we say okay, but this one has to be changed now because this is half that cross section thickness. So you go to properties, right click, local 1D property, you select that, and instead of whatever it is, we put 0.025. 0.025. Okay. Yep. We don't need an orientation point because it's a closed. It is a circular cross section. Good. Now, what do we know? We have this end is clamped. Okay. This, and let me hide these things so that it doesn't block my view. This is in the plane of symmetry. Okay, so I'm going to click on user defined, and I'm going to make sure that it says symmetry. This is so that I don't get confused later on. This point is in the XZ plane of symmetry, so there is no, this point, this vertex, no displacement in Y, rotations are exactly opposite. This takes care of symmetry. Okay, good. And let me hide this. Now I want to push this thing down. To push it down, first you have to give it 0 downward displacement. I'll say push down. Push down. Okay, this point. First to push it down, I make it 0. And then I changed it with enforced displacement, which is this. And it's going to be, how much is that? I think the downward displacement was 0.001 negative. And then you say, okay. I also want to give it a twist. So let me hide this once again. Hide that. And then I'm going to do another user define. I'm going to call this thing twisted. 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 At this point. And it looks like I'm twisting about the negative y-axis. So about the y-axis is like that. Not translation. Twist like this. Okay. And we say okay. But then we can change it. So we're going to go and change it to the force displacement on that, and I'm going to make -2 degrees. You can also use 2, but the way I've drawn it is, no, actually it has to be like that. Yeah, it has to be like that. It has to be -2. You will just lose marks for the load because the response is different. Good. And that's pretty much it. So we're going to, save it. File, save management, analysis, save as. This is in the problem 2 folder. We say OK, and then we run it. I hope I didn't forget anything. I didn't. Here's deflection. Nothing exciting. So look at the front view. It looks like that. Okay, you look at the side view. It looks like this. Okay. Now, there's a question that you're asked, and that is how much twisting moment is needed? Okay, so what I need to do is this. The easiest way of doing this problem, okay, is go and get the reaction at this clamp and look at the rotation or moment about the y-axis. That's the easiest way of doing it, and multiply it by 2. Okay, so let me go here. Deactivate. Actually, we can leave it. Put the cursor there. Right click. Create resultant sensor, reaction sensor. Select this instead of fooling around with the stuff that I put there, because whatever moment that you have to put in here is the same as the moment there. Of course, you have to multiply it by 2 because there's 2 of them. So that's the one. It's update result, and look at the moment. So moment about the y-axis. This is not the proper unit, so I better change that. So we say OK. Tools, options. Okay. I want, look at the description of the problem. It says twisting moment equal to pound-inch. So let's go find the moment here, alphabetically sorted. Moment. Magnetic. Moment right here. Not Newton meter. Pound-inch right there. You say OK. And now we double click on this. Moment, and the value is this number times 2. Okay, this number times 2, not this one, that guy. Moment about y times 2. Okay, so in that box you write down that number that you saw times 2, and please make sure you don't cancel this and you say OK, because I want to be able to see this reaction sensor to grade your paper. So you save it now, and you're good. Okay, let's go to the next problem. This is the one that you have to do. You look at this immediately, you realize that this has to be done with shell elements. And what do we have here? We have edge around this hole is clamped, okay? And the geometry is given here for you. What else do we have? And there's a pressure there. And the only thing is that these are different thicknesses. So the thickness of this is 0.025, but this middle one is 0.25. So let's go ahead and do it. We're going to do this thing as a part, right? Problem 3, part Oh, planes of symmetry. I forgot to discuss the plane of symmetry. Let's go back here. You look at this problem, there's only one plane of symmetry and just cutting it like that. Like that. Half on this side, half on that side. Half in the front, half in the back. Okay. So we have two choices. Either make half of this to begin with or make the whole thing and then split it. That's entirely up to you. So I'm going to make half of it. On the sketch, on this side view, I'm going to draw something like that. We're going to clean it up in a minute. Okay, first of all, these length are 2 inches. So dimension here, this is 2. And this is 2. And so is this. Yeah, this is 2 also. Okay, these angles are 35 degrees. So this angle from here to there is 135. Same thing on this side. This angle from here to here is 135. Okay, that's pretty much it. So you exit and you extrude it by half the width, which is going to be 1 inch. Now we're going to draw those circles as needed. So on that face, I will sketch. For example, have a circle here. But I want to make sure that it's symmetric. Exactly the easiest way or the fastest way is to make this thing from here to here 1. Okay, exit. And then we can use the saw here. You can split this. Oops, cancel that. Cancel that. Let's try it again. Saw. The element to cut is this. Cutting element is that guy. And it was the other side that we want. Oh, no. That's correct. This is correct. We want to make a hole, right? Yeah, right there. And then on that face, I will sketch that circle. Oh, I forgot to put the appropriate radius for that. That radius I didn't actually give it. I have to find out what this thing is. Control Z. Let's try it. Dimension between that line and this is. Let's zoom in. I'll do it the long way. So this line, control that line, control the center, equidistant, whatever is fastest, equidistant. Okay, that radius is in the drawing. It says thickness. Both circles are centered 0.25. So this is going to be 0.25. I forgot to do the other one. We will do that. Exit. Why don't we do a split again? So split, element to cut, cutting element. Yeah, that's good. It's just that I have to go to this sketch and clean it up. This sketch. That radius should have been 0.25. 0.25. We said okay and exit. There we are. We're pretty much done. Let's make everything out of steel. So where's apply material? On that part, everything is made out of steel. And say okay. And we're pretty much done. So now we're going to go, let's save this thing. I'm going to use file save management. File, save management, save as, desktop. desktop, new folder, problem 2, problem 3, we say okay. All right. Now we're going to go to generative structure analysis. We're going to mesh ourselves. So this is going to be shell mesh. Because of the way this geometry was created, I don't have to join these surfaces. So this is fine. So let me just make it a little bit smaller though, 0.2. Okay. And okay, good. If you want to look at the mesh, it's there. You can see that. Deactivate it. Okay, now 2D property, the thickness, we're going to make everything to begin with 0.025, 0.025, okay, and then we go to properties, right click, local 2D property, that guy is going to be 0.05, okay, 0.05, this everything to begin with was 0.025. Now this one, we're going to make it 0.05 based on the information that's given in the statement of the problem. Good. Let me hide these sketches. Let me hide these sketches. Let me hide this, hide that, hide this. Okay, good. Okay, now what do we know? On that face, we have a pressure in the other direction, 10 psi, so it's going to be 10. All right. This hole is clamped. This entire hole is clamped. Half of it is clamped. And these edges, 1, 2, control 2, 3, 4, 5. These are all in the YZ plane of symmetry. So user defined YZ plane of symmetry means does not move in X, rotations opposite. Yeah, and that's pretty much it. Save the analysis, file, save management. Here's the analysis, save as in that problem 3 folder. You can see that. And then we're going to run it. Nothing exciting. We're just going to bend. There you are. You can see that. This is the 1 meter stress. Okay. There we are. Okay, good. So that takes care of problem number 3. Okay, so let's get rid of this. Get rid of that. There's my problem number 4. We have a situation like this assembly, it says it's an assembly, so you have to do it as 3 parts. And let me see now. These are symmetric. What do we mean? These bottoms are clamped, okay? And these, it says these pieces are inserted there. End faces of the 3 pins are welded to the edge of the hole. So these end faces are welded to the edge of the hole on the top, okay? Yeah. And then what do we have here? Oh, this whole thing sags under its own weight. The gravity acts in that direction. And it's 10G. Okay, so it's on a different planet. That's fine. Okay, so use use as first of all the most appropriate element, all solids. Okay, symmetry, we need to do only half of this, so full pin here, half a pin here, and that's it. And then that's pretty much it. So the dimensions are given here for you. I'm gonna just move on. You can use the whole thing or half of it. I'm gonna make half of it. Okay, so let me go here. Start with the part file, product file, product, not part, product. File, save management, save as, one desktop, new folder, problem 4. Okay. Let me do the top piece first. So insert, new part in there. I'm going to call this thing right-click properties, and I'm going to call this thing top piece. How about that? Top and top. Okay, let's make it. Double click on that plane. I will sketch half of that shape that you see there. So it's going to be like this. We'll clean it up in a minute. Something like that. And like so. Okay, first of all, let's clean it up. This top line, control bottom line, control the middle axis. It's going to be symmetric. Let's give some dimensions here. So let's see now. Yep. This dimension is 3. And this dimension is 3. Yep, 3. Okay, now we want a half a circle here. So let me go ahead and make half a circle there. And that the radius of these circles is 0.5. So let's clean this up. This is 0.5. And I want another circle here, also radius 0.5. Oh, you know what? I just realized this should be 6, not 3. So let me double click on that. That should be 6. Yeah, that's better. And then we do a quick trim here to clean up some of these sketches. Okay, oops. Let's try it again. Let me see for a second what happens. Let's see now. It is impossible to trim a length. No problem. Say, let's say no. You know what? Let's check a few things here. What can we do to clean this up? So I'm not sure what that message means, but okay, let's do the following. Let's get rid of this. Oh, let's try it one more time. No, obviously it doesn't like it. No. Okay, so let me do this. Delete this. You have to do the problem because there's not enough time to go and find out what the heck that message was saying on a test. If you can, go ahead and redo it a different way. Okay, that's good. Exit. And then pattern. Now, obviously, you're not in part design, so you have to switch to what is that? Mechanical design, part design, and then you pad it by the thickness of 1 inch. Okay, so that's basically half of that guy. We go all the way to the top. We go insert the next pin, insert the new part in there, and I'm going to call it left pin. Do. Let's try it again. Insert a new part in there. Insert new part. I'll always say no. Right click properties, left pin, pin and left pin. Left pin. Make it. So on that face, I will sketch. On that face, I will sketch. Project that circle. You do it any way you want. Okay. Exit and pad it in the other direction by 4 inches. Oops, they do 4 inches. There. Go all the way to the top. Insert. New part. Insert. New part. In there. No. Right click properties. Center pin. Center pin. Center pin. Okay. Let's go make it. Double click. On that face, I will sketch that half a circle. Close it up because you cannot pad an open section. So we go from this point, close it up from here to here. Look, if you look at the front, from the front, you can see what happened. Exit, pad it in the other direction by 4 inches. Okay, good. That's pretty much it. Everything is made out of steel, so you go all the way to the top. Everything's made out of steel. Apply material, steel on that. I'm going to say okay. All right, save it. File, save management. And here's the product, save as. My desktop, a new folder called problem 4. Problem 4. Say okay. Oops. I have a folder, but that same name. Okay, so let me make a new folder. New problem 4. How about that? I didn't realize that I had another folder there. Okay. So everything is going to be there. The product is going to be there. The top part is going to be there. Left pin and center pin are going to be there. Now we're going to go to generative structure analysis. Okay. CAE meshes all 3 parts. There is no requirement for local mesh refinement or anything. All right. So let's go ahead and fix the bottom too. This bottom is fixed. And this bottom is fixed. Oops, not the edge, not the edge. The whole face. Let's do the planes of symmetry. So surface slider. This is surface slider. That is surface slider. So is that. Now, we know that the pins are inserted in there. So there is already contact. So I'll say here, I'll say center pin contact, just so that I remember what this thing is. For the connection surface of the pin, and hide that surface of the hole, and I do another one. This is going to be left pin contact. So for the left pin, I'm going to take the surface of it, and for the second component, I'm going to hide that and select the surface in there. And we know that the edge, these are contact. We might as well finish this thing for now. So let's go ahead and do a face-face connection. Contact is right here. This is contact, and this is contact. Okay. Now we are also told that the top of the pins are welded to the edge, or the top circular edges of the pin or pins are welded to these circulars. So let's do another one. Connection between this component. By the way, I'll call it center pin. Weld or fastened, really. Okay. And for the second component, I'm going to go in hiding and select. Let me bring this in the front. And if it's bothering me, I'm going to hide the block. There we are. This is fastened. Fastened is right here next to contact. Fasten. So it is this one. Okay. And one more. We do it on this side. Let's bring both of these in the front. Hide and hide. Another connection, and this is going to be left pin left pin what do you call it, weld? Yeah, left pin weld. So let me hide that. For the first component, I'll select the edge here, and for the second component, I'll go back there. Let me bring this in the front. Hide the pin and this edge here, and we're going to make that also fasten this. You say okay. Now the entire thing is subject to a gravity loading in the direction shown of 10 G. So we apply gravity to the entire assembly, to this and that, all of them, in the direction Y. Which is that? 600 inch per second squared. 600 inch underscore S2. Please note that my units, I have not changed them, so they're going to get converted to meter per second square. But just to show you, oops, wait a minute. Let's clean this up. This is wrong because let's first of all go change the units here. Tools, options. I'd rather do that first. Acceleration inch per second squared. There. Now I go and check my acceleration. Yeah, this should have been 0 and the other one should have been 600, and it is. Okay, good. And save the analysis. File, save management. There's the analysis. Save as. Analysis 1 in that save folder. New problem 4, right? Remember that? And then we're going to run it. Nothing exciting is going to happen. It's just going to bend forward, leans towards you. Okay. There we are. There. Yeah, so you can animate it if you want. It is doing the right thing. Yeah, okay, good. So let's get rid of this. And we go and do our last problem. It is something like this. As soon as you see this, you realize that this has to be done as a hybrid problem. In other words, this piece has to be done with solid, this piece has to be done with shell, and these have to be done with beam. These ends are clamped. And what else do we know? And the face ABCD is pushed downward by so many inches. Okay. Now, you have to use many planes of symmetry, and in this particular problem, think about it, all you need is 1/4 of the model. So you can either make the 1/4 of the model or go make the whole model and start cutting it. I'm going to make 1/4 of the model. So I go there, and you have a choice of doing this thing as a part or as an assembly. I'll do it as an assembly, okay? Let me go ahead and make the block first. So I go here. We start with the part, and immediately I'm going to save this. So File, Save Management, Save As, Desktop, Folder, problem 5. Okay. All right. We're making a block, a quarter of that block. So on that horizontal face, I will sketch a rectangle, which is 1/4 of the size of that block that you see up there. And what are the dimensions? So up there, so it's going to be 0.5 by 1. So this is going to be 1, and this is going to be 0.5, 0.5. Say OK, exit, and pad it by a height of 1 inch. Okay, that takes care of this. Now on that horizontal, same horizontal face, I will sketch basically what is going to play the role of my shell, that plate. And there are different ways of doing it. So I'm doing it as a rectangle, and then I'm going to fill it, but you can do otherwise, a different way. So this is going to be 2.5, 2.5, and this side is going to be 1.5. I'm looking at the dimensions in the drawing, which you can go back and look at it, and it's going to look like that. Okay. Yeah, okay. And you have to put a surface through this. Now, surface, you have to go to shape, generative shape design. And there's FILL option, fill this, and close it. So there's going to be a surface there. Yeah. And then I need this this arc, right? This arc. And there are different ways of doing it. For example, you can go, it's entirely up to you. So you can make a circle in space, no problem. Or you can go and do it a different way. For example, you can create a plane parallel to that. Difference, excuse me, distance 1.5. Entirely up to you. And on that, God, sorry. Yeah, it's the allergy season. So sketch, I'll draw a quarter of a circle. We'll clean it up. Okay, let's find out what's going on here. Okay, so first of all, it looks like these are coincident to each other, or maybe not. So this point, this control, that, coincident. What did I do? Undo, cancel. Let's do it differently. So let's make this control that tangent. How about that? That was a bad approach. Okay. You know what? I don't particularly like what I'm doing here, so I'm going to delete this. What is... Oh, maybe it was okay. Maybe it was okay. Let me undo that. Control Z. Okay, so look at it from the view from the front. Nope. No. Oh, you can see why I didn't like it right there. So this point, control that. Tangent. Coincident. Ah, that's better. That's a lot better. I was trying, I was salvaging some time. And then this dimension is, this radius is 0.5. Okay, that's pretty much it. Yeah, exit. Now, one thing I have to do is to join this, because without joining it, I will not be able to mesh it. I have it as a sketch. So the joining is here. Good. Everything is made out of steel. So everything is made out of steel. So yeah. So apply material. Remember, I'm making it as a part. So everything out of steel doesn't make sense. The part is made out of steel. That's what I mean. Okay, so that's it. I think we saved this thing in the right directory. Problem 5. Now we're going to go to generative structure analysis. Continuous series of solids object immediately meshes it. You can see that right there. Now we're going to mesh this, the shell. Use the ugly mesh that you see, no problem. And then give it the thickness. I think the thickness of this is based on the drawing, it is 0.05. Now remember, there is an inherent inconsistency in the way I'm doing these problems. Assuming these thicknesses are so small that it doesn't matter whether that block actually sits on the middle surface or on the top, etc. So for real life, you have to worry about these things. Good. Now we're going to mesh this guy. So beam element right there, and we give it a circular cross section, cylindrical cross section, and the radius according to the drawing is 0.025. 0.025. Remember, this is not a cable. A cable, it is a welded, perfectly welded structure. It's not a cable. Yeah, has to be. Cables can't hold up things like that. Good. So that's pretty much it. So let's go ahead and do so. This end is clamped. You can see there's a clamp here. Let's do the surface sliders. Surface slider, there is that side and this side. Okay. And these edges, let me hide the sketch here, very important. These edges, this edge entirely sits in the XZ plane of the system. XZ plane, you can see that. So there is no displacement in Y, rotation is exactly opposite. Good. And this edge, this other edge, let's uncheck all of these. This other edge sits in the YZ plane, no displacement in X, rotations exactly the opposite. That takes care of symmetry. Now we have to create connections. So we need a rigid connection between these two corner points. So I'm going to create a connection. Let me hide that, this corner point. And for the second component, let me bring the thing in the front. Hide that shell, that point. And this is going to be rigid. Rigid is not in distance face connection property. It is in distance connection property, the very first one right there. And if you are having problem, just take it from the tree. And because this is not a cable, all of these just stay. Now, the other thing is that how is this thing placed on that sheet? If it's fastened, then you create a connection between here and the surface, make it fasten. Or if you just took it and placed it there, make sure it doesn't slide either way. It says all components are perfectly welded together. If you read the problem description, it says all components are perfectly rigid, perfectly welded together. And what that means, because interpret that as connection between the face of this block and the face of that shell is actually fastened. So another connection between this, and for the second component, that, and perfectly welded means that this last one is going to be also fastened. Fasten is in the face-face connection property, this third one from the left, and it's this one. It puts the fastener sign there. And now we are pushing this thing down by some amount. So first we push it down by 0 amount. That's the way things work in CATIA. You see that? And then we can go and apply enforced displacement to that restraint that we applied in the downward direction by 0.001 inch. Yep, good. Let's save the analysis. File, save management, analysis, save as. Just, it is the right folder, problem 5. Okay, very good. And we're gonna run it. Nothing unexpected, just goes, settles down. Like a shock absorber in the car, for example, or suspension in the car. So there we are. If you're having a hard time picking the zoom, or just go and do it from the tree. Right there. Average ISO, material shading, and there we are. And this doesn't surprise you because this is a rigid block. It just moves as a rigid body, pretty much. And all the deformation comes from, actually, most of the deformation comes from the beam. And that takes care of it. I could have asked how much force is needed to push this thing down. You go and create a sensor. If you're using this, you multiply it by 4. Or if you're using this vertical force, you multiply the whole thing by 4 because there are 4 sides. That takes care of the 5 problems. Good luck on Friday. I still have a lecture with you on Thursday, though.